Hi, Vansh. Thank you for doing this interview. And before we start, may I ask you to briefly introduce yourself in terms of your background, education, research interest, and work?
Yeah, sure. Thank you, Hrvoje, for having me here. My name is Vansh Jhunjhunwala. I am from Kolkata, India, and I'm a second year undergraduate student here doing a physics degree. In terms of my research interests, like I said, I'm an undergraduate, haven't had any official experience in research, but I'm quite interested in certain fields, especially quantum information, quantum computation, and among those ones. And yeah, I think that's it.
Perfect. Okay, so you participated in QCCA 2022. What was that experience like for you, and what was it about?
Right. So QC or Quantum Coalition Hackathon was basically, as it sounds like, it's a bootcamp followed by a hackathon last year in April, I think, 2022 April. And that was really my first ever experience with quantum. So before that, I chose to do a physics degree because I knew something about quantum and I felt that, this is something that interests me. But up until I did that bootcamp, I was just unaware of how much quantum has done, or the fact that there are even actual companies making computers. Actually, fun fact, before that hackathon, the only company I knew was D-Wave. Wow. And then after that hackathon, I knew about 50 more. Right. And I knew exactly what's happening in that industry. So I think the week-long bootcamp that they had was pretty interesting. And I think I would recommend anyone who's actually interested to get to know the industry a bit more to go for that bootcamp because it's very enlightening. Right. The hackathon was, again, an amazing experience. 24 hours, we had to make something on the computer. We had to make something which basically fulfill the criteria of IBM's hackathon, which was make something where a human faces off against a quantum computer. And we thought, okay, if you're going to have a face-off thing, might as well do a game. So it was me and a friend of mine. Both of us stayed up for 24 hours. Horrible night. And we designed a tic-tac-toe, or a quantum version for tic-tac-toe. And the way the game worked was the advantage of the human came from the fact that the human knew what quantum entanglement was, and the game did not. So the game was meant to statistically optimize its chances, but it was doing classical statistics, not entanglement. I see. And that's where the advantage of the human came from. So that was our game for the hackathon. We didn't win, but I had a lot of fun coding that game. Good.
Well done for that. You were also a participant in Europe Regional Datathon Spring 2022.
Yeah.
What were you working on there?
So the data open on Datathon was basically a competition on machine learning and statistical methods. The idea was given a very large data set about a company's supply chain. We had to come up with optimization strategies or just figure out problems and solutions for the company. And I think my approach with hackathons, at least during that entire year, was if I'm going to learn something, I might as well learn while doing it. So if there was anything I was interested in, for example, machine learning, and I knew nothing about it, I would just register for the hackathon. And I think that creates a very nice environment for me to learn it because I had 7 days, I have to produce a product. So I went into this knowing absolutely nothing about machine learning, never coded a single piece of algorithm before. And then me and a friend again, we were working on this. So we started with learning a bit about how predictive algorithms work, something like knife Bayes or forests. Very simple algorithms, try to analyze data sets and basically give a solution and models. The company was a shipping company, it seems sort of like Amazon.
Yeah.
And we came up with certain predictions and certain models how we could optimize their intercontinental strategies so that the shipping delays won't be as late as they used to be. We saw like a 40% better timing for shipping delays in these routes. So that was the analysis for about a week.
Yeah. You have some experience using Qiskit. What are the most interesting projects you have done using Qiskit?
That's a good one. Like I said, the quantum tic-tac-toe was pretty fun. But there was another one that I did, which was IBM's Spring Challenge. One of IBM's challenge, I don't remember which one. Yeah. I think the project was, because before this I only used Qiskit in a very programmatic sense, never in physics. On that particular one, I saw or used Qiskit to simulate something called many body localization. Don't know much physics behind it, but they gave us a hand on the idea to simulate it and just design circuits. What really intrigued me was the fact that how different the results were on the simulator than the actual computers, because IBM lets you use their own computers, right? So we simulated on the actual computer, the noise. Jesus Christ, and there was just so much noise. And that kind of puts things into perspective. Like you hear everyone talk about noise is a big problem, how big problem. Yeah, I can see that. That was the first time I saw the problem, as opposed to just hearing about the problem. So I thought that was quite fun.
Right. You are interested in cryptography? Which one do you like better, classical or quantum, and why? Can you compare them?
Fun question. See, the thing is, I like a lot of things. I'm just exploring a bunch of tech-related areas. In terms of cryptography, I first got into cryptography because of ours, as usual, as any quantum enthusiast usually does. I again don't. I don't think I can compare quantum with you, but I think as far as classical is concerned, it was part of my refuge for when I first wanted to do something that was a bit interdisciplinary, it involved a bit of maths, physics, and CS. I thought cryptography was a really good scheme for me over there. That's why I got interested in classical. So I might learn more about quantum at some point, but I think classical will always have a special place in my heart. I think the purest notion of number theory that you use, that you go from something that you believe is completely abstract and useless theoretical math to something applicable. I think that was very nice experience.
You participated in AI programming competition called Terminal Live. Can you talk about that experience?
Yes. Again, this was also another hackathon. In one of the few weeks I was free. This seems to be a recurring pattern. Every time I'm free, I just go for a hackathon. The terminal. So this is basically a game by Citadel, I think, or Correlation One. They both similar companies. And basically, the idea is there's a game. It's like a tower defense game, and you attack other players and build your own defenses on every round given some constraints. And the idea is you have to code an algorithm to beat the other players. Experience. So we were participating. Again, I was participating with absolutely no experience, but we had a person on our team who had done the game before. So based on that, we went through a bunch of past strategies. I used the previous knowledge from the data open, snipe based and random forest this time, with a bit more statistics and just my passion for games and stuff, to be able to correspond, basically over the strategy of responsive based building, which was sort of something I didn't see across in other games. But the idea was, okay, every time an opponent attacks on a certain area, just defend that, let the other one score, and then attack on the opposite flank. We did beat all the 4 bosses on the game, so that was quite fun. So the idea was, there was 2 competitions. There was one which is against players. We lost that one, but there was another competition where you have to beat boss algorithms, and we managed to beat all 4 of them. So that was quite nice. Yeah. In terms of the gaming Terminal 1 itself, I think I did not contribute as much as I would have liked to, because this was right after my exams. I was a bit burnt out, and people, I didn't really have the expertise for what they were doing. But still, again, quite a lot of fun. I think even after this hackathon, I decided to take a bit of a break. And be like, okay, I think I need to rest a bit. Right. So you are a master's student here in Oxford? Or? Undergrad. So I'm on an integrated master's. I'm doing 3 years of bachelor's, and then I can continue on to do another year of master's. I see. Okay. So how come you have decided to pursue a degree in physics, and why Oxford? Right. Well, like I said, high school I was interested in maths, physics, and CS, and I wanted to do something that involved all of them. And very initially, when you're young and in high school, right, the idea is, if you do physics, you also do math. So I was always sure, okay, either physics or CS, because math comes along anyway. I wasn't interested in pure math. I was interested in more applied. So it was always the choice between physics and CS. And I got pulled to physics purely out of trying to imitate one person, which is Feynman. Of course. Of course. Yeah. An interesting idea. An interesting fact about my interview here at Oxford was, so when I was interviewing for Oxford, one of my interviewers, who was also a younger man, and about for 15 minutes on a 30-minute interview, all we did was talk about Richard Feynman. Yeah, he didn't talk about my interview at all. He's like, so you mentioned Richard Feynman on your personal statement. Think about it. So it's great, and he's like, yeah, I love him as well. He's my idol as well. It's great. It's great. Bonding with other physicists or Richard Feynman is the purest experience ever. Do you think Feynman is the greatest quantum physicist who started this quantum computing revolution? Is he the greatest quantum physicist? In terms of, do you mean who started the quantum computing? Yeah, right. I know that there's an idea that he was the first to suggest it, but I don't think that's what Feynman should be remembered for. I don't think that's where, why Feynman would be the best. I think if I wanted to say Feynman was the best, which he is for me subjectively, it wouldn't be because he suggested an idea or because his work in QE. I think it was purely because of the kind of passion he embodies for physics. I think that's the reason why at least what I've seen myself and most of my colleagues like Feynman. Irrespective of what part of physics he was doing, he would still be Feynman because for him it's physics first and everything else.
I see. And he's well known to be one of the best lecturers of all time.
Absolutely.
Yes.
I think every undergraduate at some point has tried to read the Feynman lectures and be like, yes, this is my. I think I read the Feynman lectures for the first time in high school. And what's great about these lectures is that the first time you read them, right, you feel like, okay, I think I understood them. But you don't realize how much you don't understand because there's a lot of subtext in those lectures. This is coming from a man who potentially knew all of physics up to his time. So there is a lot more to it, the lectures, than you realize at an undergraduate level. And I think as I do more courses now, I seem to realize that what he's saying is it's essentially as if he took the subject, diluted it down to its pure intuition. There you go.
Right. I mean, he's a genius. He's really a genius.
Absolutely.
What area of physics you find the most interesting and why?
What area of physics? Quantum mechanics obviously has to be there. Been doing for the longest time. Been into it for the longest time.
Yeah.
But I will mention of late. So this is completely irrelevant to quantum computing, but of late I've been reading. I read a book by Max Tegmark.
Yeah.
And I've been doing just looking around a bit, and I think cosmology is very fascinating. Again, don't know. I think a lot of it boils down to data analysis from what I've seen in research projects or talking to my professors. But it still seems quite interesting to me because of how much you can conclude about something like the CMBR or something like that. Galaxy formation but simply by simulations and data analysis. And I feel like that would be something I would be open to trying or just exploring a bit more because it seems very fascinating.
You held an internship position at Oxford University Innovation where you worked on quantum memory stores.
Yeah.
So can you tell us about what are quantum memory stores and what have you learned during your time there?
Right. So Oxford University Innovation was so the idea was it was a startup boot camp or startup accelerator kind of things. And the way it works is OUI controls all the IP in Oxford, right? And when they have a lot of IP, they try to commercialize it. And this program was called STEP, was designed to basically get students in and give them an IP and be like, okay, there's an IP. How do you commercialize this? Or come up with a startup and commercialize it. So that was the plan. So it was a lot more startup focused than it was technical focused. Even then, obviously, I went in and I chose an IP that I think I was interested by. Quantum memory registers developed here in Oxford. So quantum memory registers. So memory registers are basically just registers, but with a bit of memory. So it's essentially a normal register, but it exhibits a hysteresis curve, so you can trace back some of its memory.
Right.
And the way this particular memory register was implemented was using something called quantum dots. The exact feature isn't important, but the idea was because of the way it was implemented, it was very resistant to like some sort of cybersecurity attacks, and it was a physical implementation of a physically encoding device. So the idea was obviously when I saw this idea that this could have a lot of applications in something like unique signatures or anti-counterfeit. So anti-counterfeit is what we went with, and the whole month was me and a bunch of other friends preparing the startup. So looking at the technicals, seeing how this would actually work alongside real world technologies, and putting that as a startup to investors. So for example, if you have quantum memory registers, how do you put that memory register onto a, let's say, scannable NFC chip? Put it on pharmaceuticals. That was a major market we were looking at because counterfeit in pharmaceuticals is a pain point. And if you scan them, and you can scan them, have them, does it actually improve quality of security and stuff like that? And then we pushed the whole product to the VC. It wasn't the most fruitful route because there was still a bit of challenges in the actual implementation, and the IP was a few years away from actual scalable development. But I think what I learned from that experience was a lot more on the startup side than the technical side, which was just how to work in a team. I think working with, and it was a team that I've never met before. So I was working with 5 other people who I'd never met. And I was started from day one, it was just hustling because we have about 3 weeks to push an entire startup. So I think that was the biggest experience, how to handle a team. And I was the youngest one there. I was in my first year. Everyone else was around EFILs or 4th years. Despite that, I was the only one with the physics background. So I was in charge of the technical part of it. So understanding the technology. So having that level of responsibility with people who are senior to me, I think that taught me a lot. And being able to communicate with them to be able to carve my own ground, just simply that, okay, I respect you because you have a lot more experience.
Yeah.
That was quite interesting.
Perfect. So, what is your favorite quantum algorithm and why?
Oh, actually, sure. Um, I remember learning a few back when I was very early coach. I think Deutsch was quite interesting, but I think because of my interest in classical, I think it has to be short because it's what really got me thinking about when I was thinking about my whole math CS phase and I was going into cryptography. And when I heard about this algorithm, I was like, I really need to know what this is and how this works. And it took me a while to understand it. I think it was quite complicated. It took me a while to just see, okay, I see why the math makes sense. Why is this actually working? And once I got to that, I think I'm still getting there. But once I got to that, I was like, this is a very cool. This is a very cool job. I think that's what catapulted me from cryptography into quantum computing.
What would you say is the best framework for quantum computation?
What do you mean, like the hardware?
Like Qiskit, like I don't know, CERP,
I only worked with Qiskit. I have tried to work with a bit with Penny and Rocket. It's I think Qiskit is the most well developed right now, clearly because I think I had a huge head start. And so I think I would go with Qiskit just because that head start I had, also because as a Python package backed by such a language like Python, as opposed to, for example, let's say Q Sharp, backed by C Sharp. I think just being backed by Python makes it a lot more accessible. So I mean, I went into Qiskit and I have really learned that. So I think I would say Qiskit.
Who is the greatest quantum computing scientist of all time?
Who's the greatest quantum computing scientist of all time? I'm not also going to say David Deutsch. No.
Good answer.
I would tell you. The first one I ever was introduced was, again, because of a connection with the Feynman, was John Brushkin, because he was the Feynman chair of physics at Caltech. So the first resource I ever watched on quantum computing was a set of 3 lectures by John Brushkin given at Cornell, where he explains what qubits are and how they work. So I think Brushkin I had a big impression about him because that was my first introduction. I also a fun story about Brushkin. The first time I discovered physics fact exchange, right? I went on there to ask a question and I was just scrolling around. And then I saw a question saying someone had read a paper by Brushkin and they wanted to know, so they wanted a clarification. And there was an answer by Brushkin himself.
Really?
That's not about the community that I was aspiring to be a part of. So I was really, really impressed and just addicted to that idea of it. And it seemed very, because this was early days in high school, I wasn't at Oxford, I wasn't surrounded by amazing researchers all around. So the idea of being able to interact with someone like that seemed very foreign, seemed very interesting. Now it doesn't seem as fascinating because you're at Oxford, right? Of course. But at that time, it was very big. So practically, yes, but since then I've also heard the Deutsch speak a few things about him. I think he's a man of very strong opinions, and I love that about him. I think the way he explains, or the confidence with which he explains things, I think he came out for one talk that I went for, and it's clear to me that this was a man who knows what the depth of knowledge this man has is insane. I agree. 100%. Yes.
And what do you think about Peter Shor and Lon Grover and their legacy?
Peter Shor and Lon Grover's legacy. That's an interesting one again. I'm not too sure. I don't know much about them personally. I do know about the algorithms. And like I said, I think Grover, after Deutsch Josta, I think Grover and Shor were the most popular algorithms and the most useful in practice algorithms, because Deutsch Josta is still a black box algorithm. It's not something that you can apply, whereas Grover Shor came out with something actually practical. So it's in some sense, the way I think of it is, it may not be let's say it's not the best algorithm, or let's say Grover and Shor aren't the best algorithm for what they do. But the idea for them isn't to be the best algorithm. The idea, what I think is important, is they show it is possible. Quantum computing can be faster than possible. And I think the fact that they can prove that and they can show that practically is what their legacy should be. Not the perfect theory, but prove that the theory can exist.
I agree. You mentioned that you are interested in machine learning. What do you find fascinating about artificial intelligence in general?
I think all of it.
Yeah.
I think a lot of it is just it's more reinforcement learning from what I know. The idea of being able to mimic things without a proper optimization algorithm. I think that's pretty interesting. And more recently, I've been into a more philosophical debate about artificial intelligence because I went to a few lectures by Roger Penrose.
Yeah.
And he has some very interesting theories about why or why not AI can never be conscious.
Yeah.
And it's an interesting question. Usually, when I have the debate, it boils down to what do you define as consciousness, or what do you define as free will at that point.
Yeah.
But it's quite interesting to think about to what extent can AI actually emulate humans, because in terms of being able to make decisions or optimize things, I think that's a field. I think I don't think it can solve problems, at least like well-defined clear goals, problems, games, whatever you call them, much better than humans. I think that's not debatable.
Right.
But can it do the other things? Is it capable of something like EQ? Is it capable of free will? Is it capable of doing things on its own? Is the idea.
I believe that only time will tell. So
absolutely, yeah.
Wait,
Also, I think it's an interesting idea. I went to another lecture by Dennis Savage from DeepMind. Yeah, he was in Oxford at some point. I think there was something very interesting he said, which was a lot of people think about their problems as problems. Because, what if the whole idea of AI can get out of hand?
Yeah.
And the way he said, or the way he put it as something that I really like to quote is, if you the consequences, a few bad consequences of something that you might do is no reason that you shouldn't do it. Like just because it might go out of hand, it might go wrong, is no reason for you to not do it. I think the more physical or more scientific approach is do it and then find better ways to constrain it. I think it was the same psychology used by Feynman during his Manhattan project, which was I'm not going to not build a bomb because it's good deal with bad things. If I can further build by building a bomb, I will do it. And then I would find a way to make sure the bomb never gets used.
I see. Yeah.
That was quite interesting to me.
What do you think about ChatGPT? Are you surprised by its power?
Yes. I think ChatGPT was. I did play around with it for a few days. It's quite bad at math. Not gonna lie.
Yeah.
I think it once proved to me why pi was odd, and the other case it proved to me how entropy always decreases in systems. So can't really do science, but again, I don't blame it. It's not really made for science. I think what it does really well. Obviously, it's really creative. So ask me to write like letters, poems. I think it works brilliantly. But what really surprised me was because GPT could do that as well. So GPT could do the creativity as well, and I think it was slightly more creative, if I could say that. But what I like about ChatGPT is that it can hold different conversations, and when you refer back, so for example, I'm having a conversation with you about quantum computing, and suddenly I change subject and say about football. And then 5 lines later, if I come back to quantum computing, you would know I'm talking about the same conversation, right?
Right.
And if you write on like something like Siri, it wouldn't work. But ChatGPT can pick that up.
Yeah.
Like as long as in the same conversation thread, it can relate conversations the way humans do. It's not forgetting things. And I think that was very impressive.
How well would AI and quantum merge together in future?
How well? Well, it's too soon to say. No, I think both cutting edge fields. In some sense, there's always a need for some classical backend to every quantum system. Or at least that's what I think. I think the way quantum systems are right now is the idea isn't to make a full quantum system that you can type quantum mechanically or whatever. And you'll always need a backend. So you'll always need, for example, let's say you were trying to do a search algorithm to find some hidden descent something for some problem. You wouldn't want to optimize the parameters humanly because that would be a very painful task.
Yeah.
So you would obviously need AI could be a great thing to do that. So AI could actually optimize parameters and then quantum could do the actual search. So there's a lot of synergy there. And obviously we do need some normal classical backend for every quantum system, at least the way it's designed right now. So I think there's a huge potential for that. And I think there's already some companies doing that and going into that. I think Sandbox, which we had last year in Oxford for a talk, they're doing some pretty good work in terms of finding commercial synergies for combining AI with quantum. So I think it's definitely possible.
What got you interested in blockchain, and are you investing in crypto?
What got me into blockchain? Again, it was So what first got me into blockchain was again doing my cryptography things. I learned about how blockchain cipher work, how SHA-256 and all those works, and I discovered okay, blockchain is an implementation for that. Up until I came to Oxford, blockchain was simply a technical fascination for me. But once I came to Oxford, I interacted with people here. The whole idea of Web3 and startups around it. I think it's sort of like my technical and my startup world collided, and I got into a bit of blockchain stuff because just seeing how startups in blockchain industry work. I'm gonna say something not completely fair. I don't believe in blockchain particularly, in the sense that I think it's a great technology. I think it's a pretty useful use cases.
Yeah.
But the way the community or the Web3 community puts it out is just sad.
Really?
Yeah, I think
what sense?
In the sense that the way blockchain is being used, I think it's being used for the sake of using blockchain in most cases. I think a lot of things that people are trying to do with blockchain could be much better done with just normal technology. Especially the kind of, I think NFTs are a big problem with that. I think NFTs, if used properly, so I've seen an implementation of NFTs using something called tokenomics, which is it's basically a way to democratize things in the blockchain. So the people who own NFT also essentially own voting tokens. I think those are interesting things because those are specific to blockchain. Yeah. But using NFTs simply as collectibles or tags when you can do it classically, I don't see the point of it.
So you don't invest in crypto?
Oh, I am invested in Ethereum.
Oh yeah, okay.
I made a little investment purely out of just to see, just to put my money where my mouth is. Made a small investment. Isn't doing too well since FTX. But I think blockchain is a very interesting concept, but it's been slightly misunderstood. I think that's what I think. It's slightly misunderstood in the way people around here approach it. Like I think I've gone back to the more, this is a great technical solution. Like, let's find a problem that actually suits it as opposed to just shoving it down every single thing just because we want it.
Right.
I think that's the more appropriate response to blockchain.
Yeah. And one final question: how do you like living and studying at Oxford?
It's absolutely fabulous. I think. Look at that! If you can walk out to that every morning, I think it's phenomenal.
Yeah.
I don't think I'm one of those people who hasn't been around enough because I like to study in my room or like closed spaces. And it's easy to take it for granted when I'm usually walking down the Yadkan or the streets here. But it's sometimes so surreal that I can actually be here. I think one of my I think after this is the beginning of someone else, which was we had a guest over for one of our events last term, right? And he's a 70-year-old man, and he's really interested in one. And he's in the States. He's never been to Oxford before, but the moment he landed, he was like, I never thought I could be in this hub of physics and maths in the entire world. And the way he was fascinating over this thing made me realize it's true. It is a hub. I am at one of the best places for maths and physics in the world. And I don't think you don't appreciate it day to day in daily life, but it's always there in the back of it. There's diversity of it. I think I love it. It's absolutely. I wouldn't be anywhere else.
Right. Vansh, thank you so much for this conversation.
Absolutely. I hope I was of some help.
Yeah, of course. Thank you so much.
Yeah, absolutely.